Yo, GK. Ah, it's GK. Hey, I almost say it up on the thing, yeah. Eh? Oh, yeah, I fix something now. Oh, you work for your home now. So you work for your yard. See if we can do a shot of a one work here again. No, gaming machine. Acer. Say it not turn on. So I'm gonna see if we can fix it now. So we can give the technician it by if he can link the feed today. In the morning, yeah. I want it. Plug in the charger. Nah. Press it but not now 1 feet. Nah, turn on. Nothing on the current display. Nah, turn on. UB Tech. Hello. UB Tech. Where is this? Who is this? UB Tech from where? Yeah, dead. No power. Who is UB Tech? Where are you from? Iraq. I'm a random follower from Iraq. Oh, Iraq. Okay. Tight. Alright, so this is a 400 series chip PCH 400 series, right, which matches the 10th and 11th generation. So this is a 10th gen CPU, and we have a dedicated graphics card here as well. Right, so it's an Acer typical gaming basic entry-level gaming laptop. But it can do the work, but it's not turning on. Alright, so it's a 300 series PCH, which is paired with the 10th generation, 400 series SRJ-AU, which is paired with the 10th generation CPU. Yeah. Alright, so I'm gonna check some resistance now. Alright, so first I'm gonna check the PCH side first, because these PCH, the 400 series easily die. They're easy to break. So I'm gonna check the BIOS pin number 8 as usual. And it's good, so the PCH have some life. I'm gonna check the 19 volt rail as usual. Oh, and we have a dead short to ground here, as you can see. See that? We have a dead short to ground here, so this is a problem here. Alright, I normally use the burning method. Burn the board. Use the thermal camera to see where the short is. But first I have to check all coils first, because I don't want to put too much voltage in there. And if it's a broken MOSFET, if an upper MOSFET is broken in any of the PWM circuit, then most likely the CPU can be dead, the graphics card could be dead, right? But the PCH is okay. Or it could be a simple capacitor on the 19 volt rail that is break down. Right, so I'm just visually inspecting the board. So I'm visually inspecting the board to see if I see any burn. And I don't see any burn. Alright, so let's check the rest of the coils. So I'm going to check the standby, 3 volts and 5 volts. And that's good. 362. That's also good. Hi, I am from India. Alright. Yeah. Alright, RAM supply. I think this is for the RAM. Right, to confirm this with the RAM. If I take out the RAM, it should increase. See that? So it's 181. If I put back the RAM in it, it should decrease. See that? So this is for the RAM supply. So that's also good. Next we have the graphics VCC ST. That's good. We have the graphics card core supply. That's good. That's good. That's good. Alright. I have the VIA memory. This is for the VRAM. That's good. VIA memory is good. Alright. VCC SA and VCC IO. VCC IO, VCC says good. Chipmaster, can I have a question? In one of your videos, you get a motherboard where you connected the ACS to the ground, turn on like a charm. Could you explain? Um, that's a trying to remember that video. Oh, that video, yeah, for the BIOS chip, eh? Pin number 1. It's just a quick way to indicate if the BIOS is corrupted or not, which is causing the power failing. CPU core, that's pretty good. Graphics, also good. So we have 3 phases for the core, and we have 2 phases for the VCC GT, the integrated graphics, and they're all reading good. Alright, so there's no short to ground on the coils. We have a battery coil here, and that's pretty much good. So I think I should just burn the board. Alright, so let's burn the board. Well, first of all, let me check the adapter, reverse bias MOSFET. That's good. Next MOSFET. It's also good. So both MOSFETs are good. Input MOSFETs. Alright. So let's get the board ready for to be burned. What's this method called? You never seen that method before? No, you have never seen that method before? Really? That's interesting. Okay, so I'm injecting roughly 6 volts on the line. It was very... So you tried it and it worked for you? It was a miracle for me. Miracle. Miracle. What? Oh, miracle. So you like the idea? Alright, so okay. Just wait. I've never seen a video in YouTube. I've never seen a video in YouTube talk about it. Yeah. What's wrong here? Hold on. Okay. Alright, so I'm gonna pull up the camera now. Screens are falling. Alright, so let's take a look at the screen. So as you can see now, I'm going into the thermal mode, and then we are going to check. First, I'm going to check in the CPU area here first, in this section here, right in the CPU here, and then right. Right. So we're going to check here first. Alright, so I'm going to give power. I'm going to give power now. Alright, so I'm getting. Uh-oh. You see that? Can anybody tell me what's that? See what happened? Can anybody tell me? Let's do it again. I'm going to lower the voltage. Give power again. See that right here? This is pointing to the CPU, right? My CPU is broken. The CPU died. Anybody can tell me why the CPU died? What is causing that short? My CPU has died. The CPU died. It's shorting. replace the CPU. But normally, as you know, this is caused by a broken MOSFET, a broken PWM MOSFET in the upper MOSFET in the switching side. So what I normally do to find this, inject 1 volt. So I'm injecting 1.5 volts now, and I should get it back registered on any of these coils. Yeah. Let the CPU slightly warm. Alright, so I'm checking VCC SA, I'm not getting back the voltage. VCC IO, I'm not getting back the voltage. I'm checking the core now. And I'm getting some voltage here, as you can see. I'm getting some voltage on the core. I'm checking the graphics, not getting any voltage. So the voltage on the core is broken. See that? So I'm getting back 0.6 volts here. See? So this is indicating to me that our upper MOSFET is broken, right? And this uses dual MOSFETs. Alright, so I'm getting voltage here. So one of these dual MOSFETs in the up is broken. So I'm going to remove it. Let me go under the camera. See if we can find something. Alright, so we have 3 dual MOSFETs. So we have one phase, what I will do, I remove one first and give power to the board. Alright, so this one. So, pin number 3. Oh, I forgot to turn on the camera. I forgot to turn on the camera. Alright, so you can see what I'm doing. Alright, so as you can see, I have one MOSFET here. Right, so as you can see, this is pin number 1, this is the gate. Right, this is the gate for the upper MOSFET. Right, pin number 2, 3, pin number 2, 3, and 4 is, right, pin number 1, 2, 3, and 4 is the upper MOSFET drains pin. Right, pin number 5, 6, and 7 is the ground pin, and pin number 8 is the lower MOSFET gate switch pin. This is the gate pin, right? So to confirm, I have to put my meter on ground, red probe and ground, black probe and source on the 5, 6, 7 pin. As you can see, I'm getting ground. That is correct. I'm checking the gate pin now. It's also shorted. So that indicates that. Alright, so I have to check it for all 3 of them. So as you can see, I'm getting a short here. Let's check the upper MOSFET gate pin now. As you can see, I'm also getting a short. And the pin number 2, 3, and 4, which is the upper MOSFET drains pin, and I'm also getting a short. So let's do the same for the next one. See, upper MOSFET gate, I'm getting short as well. Pin number 1, 2, also short. This is the upper MOSFET drains pin. Right, pin number 5, also short. And the gate, also short. Alright, and let's go again for this one. Number 1. Oh, sorry, I was on that. Could you tell me that time my meter was on voltage mode? My meter was on voltage mode. Couldn't you have told me that? My meter was on the voltage gauge. It should be on diode gauge. Let's try again for the first one. Oh, God. This is a good. Alright, so pin number 1. I'm getting 442. Because I was wondering, how am I getting short reading in all pins? That's not normal. That's not normal. So this is the upper MOSFET gate. This gate is giving me the 441. That's good. But the pin number 2 and 3 and 4 will be shorted. Look. See that? That's the drain pins. Now pin number 5, 6, 7 is also going to be ground for the lower MOSFET. Right? And pin number 8 is the lower MOSFET switch. So that MOSFET is good, isn't it? Right? The gates are reading good. Let's check the next MOSFET. Pin number 1. The gate is reading, alright, 440, 439. This is going to be short for the upper MOSFET drain. Lower MOSFET pin source, also shorted. And I'm checking the gate, also good. Let's check the next one. Aha! I got a short here. I got a short here. And I'm getting pin number 2, 3 is going to be shorted. Alright, pin number 5, 6, and 7 is going to be ground for the lower MOSFET. And the 8th pin is the gate for the lower MOSFET. Alright, next one. We have pin number 1, which is the upper MOSFET drain. 8 pin. Alright, that's good. Alright. Alright, pin number 2 shorted. Pin number 2 and 3 is connected. Pin number 5, 6, and 7 is the gate, is the lower MOSFET source pin, which is connected to ground. Alright, and the 8th pin is the gate for the lower MOSFET. So my MOSFET that is broken is this MOSFET. As you can see, the upper MOSFET gate pin is shorted. So this is broken. So I'll replace this one. It's giving me a short reading. So I find the MOSFET. So that's how you can check dual MOSFET. See? The gate. So you use the gate pins. So I found the faulty MOSFET. Alright, so I'm going to remove this MOSFET. Alright, so this is the MOSFET. Alright, this is the bad one. Alright, so I'm gonna remove it. My short pin here, my wire for short detection. Move it out of the way. Alright, so let's get rid of this MOSFET. GK, you watching GK? GK still there? Alright, the ground plate on this board are very tough, so I have to increase my temperature. There we go. Alright, so I removed the faulty MOSFET. Let's check the resistance to ground now and see if we get some good reading. Right. So I'm checking adapter input current sensing resistor first. So as you can see, it's now increased to 200. It was short to ground before. A typical normal value should be 3 to 400 ohms. And I'm getting 324. The board is hot, so when the board is cool, it increases. And this is good. So the short is removed. So it's a MOSFET that was broken down on the line. damaging the CPU, burn the CPU, so the CPU will have to be replaced. But you have to make sure you remove this MOSFET first, because if you don't remove this MOSFET and install a new CPU, then the CPU will die again and you will cry. And you have to refund back the customer's money, because you'll take a down payment from the customer to buy the new CPU, put the new CPU on the board. Once you plug power to the board, you have to refund the customer their full money. So I'm getting 380 now, so the short is cleared. But we have to replace the CPU. I'm going to see if I can find on a donor board. I'm going to see if I can find on a donor board. Alright, so I'm going on the road now. So I'm going to resume back the part 2 of this video for the replacement of the CPU after I get back from the road. Okay? Yeah. Since GK is not there, he's gone. Everybody's quiet today, all watching and keenly watching and observing. Alright, so I'm going to go on the road now and get back with part 2 of this video for the CPU replacement. Right? And that should be it. Alright.